Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Function Basics, the inverse of a function. The odds of someone doing exactly what you tell them to do is slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. If I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose by ordering and purchasing the complete cram session or even the function basics, okay? You have lots of friends, classmates, peers, and even sometimes colleagues who are taking Algebra 2 with you as well. Spread the word and tell them to inbox me at memedicine@gmail.com so that they too can purchase their healthy dose. You'll be glad you did because they'll make great study buddies. Function basics. How does one find the inverse of a function? Definitely press pause if you need to, and I'll definitely give you a moment to think. Oh, okay, yeah. While you're thinking, there's a major caveat. The function has to be a one-to-one function. So this should really be, how does one find the inverse of a one-to-one function? And remember that a one-to-one function can be determined by the horizontal line test. That is, the horizontal line can only intersect the function at one point, like it does for the red and the yellow functions, but not for all the others, okay? All right, hopefully you've had enough time to think. So basically, the inverse of a one-to-one function is found algebraically by switching all the x and y values, okay? That's basically all you have to do graphically, well, algebraically, but graphically you would flip it about the line y equals x. And this is a derivative of the line y equals x if you shift it down here to the origin. So you would flip it or flip the function about a line that equals y equals x, okay? Yeah, I'm confusing myself a little bit, all right? Again, algebraically, the inverse of a one-to-one function can be found by switching the x and y coordinate pairs. So you switch the x and y in each coordinate pair of the function, and then you solve for y, okay? But I'm going to show you exactly what I mean in a few seconds, okay? And the way you express the inverse of a function visually is to write f inverse of x. And be careful, this is not a negative exponent, okay? It does not mean this, the reciprocal of the function raised to the first power. That's not what it means. What this does mean is that f inverse of x undoes the original function f of x. Okay, it's the opposite of it. I know I'm probably still confusing you, but let me get a little bit more conceptual. Let's say that x equals x equals x. Okay, I think we can handle this and we would all agree that this is true. But what if we were to go ahead and say that f of x is equivalent to f inverse of x is equivalent to x? Well, this may or may not be true. The only instance I know where it is true, there may be a few others, is when we have the function y equals x. That's xy notation, or when f of x is just equal to x, okay? Yeah, that's the only instance where I know it's true, but let's say we don't have the simple function f of x equals x. We could not say that f inverse of x is equal to x. Well, what if we were to do this? What if we were to say that basically f inverse of x of f of x, f inverse of f of x is equivalent to f of f inverse of x, which is equivalent to x. And actually, this would be a correct, accurate statement because these two functions basically cancel each other out, okay? And again, to answer the question stem, the original question precisely, Algebraically, you determine the inverse of a function by switching all the x and y's, or f of x's, the results of the equation, and then solving for y, or f of x. Okay, I'm probably still confusing you. So let's do a quick demo with numerals and not just alpha variables, okay? Let's say, for example's sake, that f of x is equivalent to x cubed, or x raised to the third, or x raised to 3, minus 5. And then we're asked to find f of f inverse of 2. Well, if you watched the previous Cram session, or if you had purchased the entire series, you would have known that compositions of functions, because that's what this is they're read from left to right, but they're actually analyzed from the inside out, or they're analyzed from right to left. So the first thing that we're going to do is analyze f inverse of 2, but we know what f of x is. We don't actually know what f inverse of it is. So let's do what I previously told you. Let's find f inverse of f inverse of x algebraically by switching all the results and with the input variables, and then solving again for the result, or switching the x and y's. So this is f of x notation. We're going to use xy notation. So these two terms are interchangeable, y and f of x. So we're saying that y equals x cubed minus 5. Now let's go ahead and switch our x and y. So this is now the beginning of solving for f inverse of x, okay? And now we have to go ahead and solve for y. So we're going to do that by isolating y by itself. And in order to do that, we're going to add 5 to both sides and flip switch the left-hand side with the right-hand side to keep things neat. And here goes what I'm talking about. So we just brought this over here, and we added 5 to both sides of the equation. Then we end up with y raised to 3 is equivalent to x plus 5. Now, in order to get y, or f inverse of x, we have to take the square root of the left-hand side, not the square root, the cube root of the left-hand side. So we're also doing that to the right-hand side. So y, or really this is f inverse of x, is equal to the cube root of x plus 5. So here goes our inverse function. Yay! This is f inverse of x, okay? But we're asked to find f inverse of 2. Our x here is going to be 2, so let's go ahead and do that. So f inverse of 2 is going to equal the cube root of 2, because we substituted 2 for our x plus 5. This is obviously going to be equivalent to the cube root of 7. I don't know about you, but I'm not interested in analyzing this right now. So I'm just going to go ahead and plug f inverse of 2 into the function f, this original function here. And when we do that, we get that f of f inverse of 2 is equal to the cube root of 7. That's what we're substituting right here, raised to 3 minus 5. Well, we know that cubing, or raising a cube root to the power of 3, just basically is going to cancel out the cube root. And so what we're left with is 7 minus 5, and that's going to be equivalent to 2. And yay, this is what we started out with. So our whole point is proven, that the inverse of a function basically undoes the original function, okay? So I thank you for tuning in, and purchase the whole session. Bye.